Dear math lovers, welcome yet again to another problem from our channel, Solutions from the Book. Today we have selected a system of equations from Kyrgyzstan Math Olympiad of 2009, and please bear in mind that all the problems that our channel posts are actual Olympiads and not some clickbait names like some other channels might do. So this is a channel which has been opened only for the pure passion of mathematics and for the passion of elementary solutions to problems given in high school Olympiads around the world. So from this Kyrgyzstan Math Olympiad of 2009, we have selected the problem. Find all the solutions in the set of real numbers for the following system of equations. X plus y squared is equal to y cubed, y plus x squared is equal to x cubed. Please pause the video, try to find the solution, and let's compare our solutions at the end of this video. If you have followed some other videos from our channel, you already know the drill. We hide the solution in order to go through step by step together. Please bear with me, because in this case, to have elementary solution, we will have a little bit of heavy detailed solution and heavy, let's say, with heavy mathematical operations. So let's start. So we are asked to find all numbers x and y from the set of real numbers such that they fulfill the system of equation given by the problem. So with these two equations, we start by subtracting side from side both equations of the system. So we subtract the left-hand sides and the right-hand sides on both given equations. We will have that x minus y plus y squared minus x squared is equal to y cubed minus x cubed. What we do now, we do some factorization. We have minus 1, which multiplies y minus x, plus y plus x times y minus x, which is the expression over here. And we have the factorization, the famous factorization of the differences of two cubes, which is y minus x is multiplies y squared plus yx plus x squared. We can see directly that there is a common factor for these three expressions, which is y minus x in the three of them. So what we do, we take everything from the left-hand side to the right-hand side, and we will have that, as I said, y minus x is a factor in the three of them. We factorize y minus x, which multiplies x squared plus xy plus y squared minus x minus y plus 1 is equal to 0. So we have the multiplication of two factors is equal to 0, and we call this the equation number 1. Now we know that we see that the equation number 1 is possible, parity is possible, only if x minus y is equal to 0 or x is equal to y, or the expression over here, all of it is equal to 0. We study now these two cases in order to find the solution of this given system of equations. The first case is that x minus y is equal to 0, or that x is equal to y. So what we do over here, we substitute this given expression in the first equation of the system, and we will have that x plus x squared is equal to x cubed, or we bring everything on the right hand side, we will have x cubed minus x squared minus x is equal to 0. We factorize x, and we will have that x which multiplies x squared minus x minus 1 is equal to 0. And this is only possible for the values of x is equal to 0. Or if we solve this simple second degree polynomial, we will have that x is equal to 1 plus the square root of 5 divided by 2, or x is equal to 1 minus square root of 5 divided by 2. These two roots are the roots of the second degree equation that we see over here. So in total, for the first case where x is equal to y, we have three solutions from the problem. Given that x is equal to y, these three solutions are 0, 0, 1 plus square root of 5 divided by 2, and 1 plus square root of 5 divided by 2. And the third solution will be 1 minus square root of 5 divided by 2, 1 minus square root of 5 divided by 2. So we found three solutions of this equation for the first case that we deducted up here. Now we have the second case, which is that the expression here is equal to 0, or that x squared plus epsilon, sorry about that, plus epsilon squared minus x minus epsilon plus 1 is equal to 0. So this expression should be equal to 0. So what we do over here to find the possible solution? We multiply both sides by 2, and we will have that this side multiplied by 2 is equal to 0. And now we regroup all the terms on the left hand side of this given equation, and we will see a very particular condition. We will have that x squared plus 2x epsilon plus epsilon squared plus x squared minus 2x plus 1 plus epsilon squared minus 2 epsilon plus 1 is equal to 0. We regroup and we form the squares on the left hand side, then we will have that this condition over here is equivalent to the condition that x plus epsilon squared plus x minus 1 squared plus epsilon minus 1 squared is equal to 0. We call this the equation number 2. Now, given that these three factors are always positive or at their minimum equal to 0, in order to have parity in the equation number 2, the three factors on the left hand side should all be equal to 0. So in order to have solution for equation number 2, all three terms are greater or equal to 0. We should have that x plus epsilon is equal to 0, x minus 1 is equal to 0, and epsilon minus 1 is equal to 0. Or that x is equal to minus epsilon, x equal to 1, and epsilon equal to 1. This set of equations is impossible because, as we see, x is equal to 1, epsilon is equal to 1, and x should be equal to minus epsilon. So we do not have any possible solution from this set of equations, which tells us that the case number 2 does not produce any solutions for the initial given set of equations. So in the second case, there are no solutions. At the end of this problem, we can say that the only solutions of the given system are the one that we found in the case where x is equal to epsilon, and we found three solutions which now repeat. 0, 0 is one solution, 1 plus square root of 5 divided by 2 and 1 plus square root of 5 divided by 2 is the second solution, and 1 minus square root of 5 divided by 2 and 1 minus square root of 5 divided by 2 is another solution. So this concludes the proof of this problem. As always, please help our channel grow, of course, if you like the content of this channel, and help us by liking, commenting, and subscribing to our channel. Thank you for your time, and see you on our next videos. Goodbye.